Hello, my name is Eli Munoz.
My name is Carlos Torres.
My name is Saul Rodriguez, and we are discussing Chapter 9 of the Fundamentals of Building and Construction. This chapter has to do with stone and masonry. We're going to go into depth about how the material is used in construction, how sustainable it is, how it affects the environment, the different techniques that are used with stone and masonry building, um, the maintenance and preservation that has to be used to keep the concrete stable. Um, there's different types of units that we're gonna go into, the properties of concrete as well. Um, there's different types of mortars and joints, and the there's different types of thermal and moisture control aspects in each of these. They also have their flaws as well that we're gonna go into depth on. So, um, masonry is used as a construction technique that it has been used like historically throughout like all of time. Masonry encompasses stone and concrete materials and is valued for its strength, fire resistant, and aesthetic appeal. This section, right here to the right, it shows how like how it is still used and has been used throughout time, like in one shape or form. Um, It is used in structural and decorative applications, setting the stage for an exploration of different masonry types. These have been used, like I'm sure you guys have seen buildings, like the cinder blocks. Those are this type of construction. They're seen everywhere. So, as I mentioned earlier, stone is one of the earliest, like oldest building materials, and it's prized for its natural beauty and strength. Um, There's various types of stones, including granite, limestone, sandstone, and marble. Each have different levels of like thermal intake and strengths, obviously. Um, it also these come from quarrying, that's when they dig into the ground and start like looking for a specific type of rock or concrete. They also use cutting. They obviously make sure the rocks are able to be used, and they have to go through a process before they are ready to be shipped off to the construction site. Stones are classified based on their geological um their geological origin and their physical properties. Um, there's ingenious sedimentary and metamorphic stones, and this is all based on their like formation and their characteristics. And depending on the build, it would be depending on their like how their construction purposes are able to be used would be used according to the project, you know? So let's say for like if you wanted a stone that looked beautiful for just aesthetics, then you would get a rock that looked beautiful, right? It might not be strong, but it looks aesthetically pleasing. Um, and if you want to use some type of stone that is used for a wall, like for a structure, you would want it to have to be able to be like support more weight, right? Not fall apart or fall apart. Well, yeah, fall apart over time. Um, and there's differences in like every type of rock, as I mentioned, they have different durabilities, they have different appearances, and even their workabilities are differences. Um, as you can see here, there's different rocks I mentioned here. There's granite, um, limestone, which are softer to shape when you're building, and metamorphic stones like marble, which are beautiful and also are very tough for construction. There's also different ways to apply masonry. Um, there are different ways to assemble stone structures is like there's rubble, ashlar, and dry stack techniques. Um, these are all important as they are very precise on cutting and fitting the mortar applications and the jointing patterns to ensure that the buildings have enough strength, stability, and aesthetic depending on if the concrete is visible or not. The There's a lot of consideration into thinking about what you're gonna put on top of the stone. Sometimes like a foundation a foundation can be made out of stone or concrete. So you have to think about how tall the building is gonna be and if the stone or masonry that you're using, um, like if it can't support that building, it's obviously gonna fall. But you must take into account like the weight, the compressed strength, and the load distribution of your building along with the foundation or just the walls of whatever you may be building. Um, uh, you have to think about the thickness of the stones, the support systems that you may be adding, the reinforcement techniques, and make sure that the structure is safe so that the building lasts long and the construction, like while it's being constructed, it isn't that difficult. Um, there's a lot of buildings that fall because they weren't built properly, but with the proper applications, it will be a long-lasting building. There's obviously many things in the natural environment that we can't control and have an effect on our our buildings, and especially with masonry, um there's methods that are used to conserve this concrete or rocks. Um well, obviously, the weather is an aspect that we can't control. The moisture in the air or just water, anything can start to affect concrete over time. Um, it can lead to cracking, or even like plants start to grow and get into the concrete and can begin to, disform them. Um, there's different cleaning techniques, through like chemical treatments that allow for the concrete to remain stabler and not no growth in between it. Um, there's also sealants like that wouldn't allow for any growth in between, not even like even some like no oxygen getting in. Um, obviously this is only for exposed concrete. If it's inside of a wall and there's thermal like insulation, it should be fine, but um there's also restoration methods that, like, after a long time, they help, like, if the concrete is already damaged, it helps expand the lifespan of the concrete and maintain the appearance of stone structures. Like the Colosseum, for example, it's been there for many hundreds of years and it's still intact. It's obviously gone through many preservations and it was built amazingly with concrete mixed with volcano ash. So it's extra durable because of that, but regardless, it had to be constructed perfectly and very well taken care of. So the concrete masonry units, or as in short, is CMU. Um, these are the concrete blocks I was mentioning earlier. These are versatile building materials. They're they have uh like very simple composition, very square square like. Their manufacturing process is pretty simple. They are pretty much just poured in and then just shipped out. They have some good advantages. They're pretty affordable. They're strong and they're easy to use, they're basically like Legos. Um, there's hollow ones and there's solid ones that are completely filled in. Um, they're really good. They can be used for any type of construction, to be honest.
So as Saul was saying, concrete mason blocks, they're very versatile for construction. They're valued for their durability, thermal performance, and fire resistance. This section explains the physical and mechanical properties of concrete blocks and how they can be tailored by altering ingredients, shapes, and sizes to meet specific construction needs. Um, The density of the blocks can be adjusted for specific applications, such as lightweight blocks for insulation, or they can, I believe the most common size is 8 by 8. They can be used for structural walls and as well as just for fences. The durability is enhanced by proper curing and designed to prevent cracking and water. There's also mortar for masonry construction. Mortar is the adhesive that binds masonry units together. This section describes the composition of mortar, including cement, lime, sand, and water, and explains how variations in mixed proportion affect its properties, such as workability, strength, and durability. Um, the workability and strength of mortar depends on its proportion. It must be applied consistently to ensure proper bonding and load distribution. The um, the mortar sometimes it comes in a pre-mixed bag, or they have to mix it on site. They have to mix it with lime or sand, and depending on how much water they apply, it would give you the right consistency for construction. So the masons that are applying this the mortar to the bricks, they use different types of joints when doing the construction. Mortar joints significantly influence the appearance and performance of masonry walls. This section covers various joint profiles such as concave, flush, and rake joints, detailing their impact on water resistance, structural ability, and aesthetic appeal. Um, as you can see there, there's different ways they can apply these, as you can see in this visual. Um, Properly executed joints prevent moisture infiltration and ensure long-term durability of the exterior of a building. And masonry improves the strength and resilience of the structure. Reinforcements such as steel bar strengthens masonry walls against tension and lateral forces. Vertical and horizontal reinforcements are placed within masonry units or grout-filled cavities. Reinforced masonry is essential in regions with seismic activity or high wind loads. Structural masonry walls. Masonry walls can be solid, cavity, or veneer walls depending on load requirements. Cavity walls include an airspace for provided insulation and moisture control. Structural walls can act as load-bearing elements or enclosures for non-structural purposes. Um, as you can see, the masonry includes either cement blocks or bricks, or it could be stone, and they can be arranged in different patterns for specific purposes. Um, like this one that is showing a typical masonry cavity wall is showing the cement blocks with an air gap in between the masonry blocks and the exterior, which would be a layer of bricks to give it both structural support and insulation. So masonry walls must regulate thermal movement and moisture to prevent damage. This section explores insulation techniques, vapor barriers, and drainage systems to manage heat transfer and water infiltration, enhancing the durability and energy efficiency of masonry structures. Um, there is there's ways they can apply moisture control, such as drainage layers and vapor barriers to prevent water damage. There's also proper detailing at joints and openings, which minimizes thermal bridging and moisture penetration. Finally, there's architectural applications of masonry. Masonry allows for creative designs through patterns, textures, and varied materials. Techniques like coursing, which would be the horizontal alignments of units, and bonding enhance aesthetics. Masonry integrates the structural and decorative functions, adding character to buildings. Um, they can be arranged in many different ways to achieve any kind of desired visual effect. So they're excellent for architectural purposes.
Okay. Seismic design and masonry construction. Masonry structures, while durable and fire resistant, can be particularly vulnerable to seismic forces if not properly designed. The main challenge lies in their brittle nature, which makes them susceptible to cracking and collapsing under the intense lateral movement. To enhance seismic performance, several strategies are implemented. Um, One is reinforcement techniques. This one incorporates the steel reinforcements such as like river within masonry walls, significantly improves the strength and durability. And another one is the anchoring system. This one is properly anchoring walls to foundation like and roofs to prevent like the structural separation. In this one, the metal ties and connectors help to distribute the loads more evenly and reduce like the risk of collapsing of the building. And another one is like the energy dissipation and movement accommodation. This one is just designing walls which with movement joints, flexible connection, and diving systems. This one can help to absorb the seismic energy and reduce like the structural stress. Um, Therefore, for this part, like there are also like building codes and standards. And these ones is to other to the modern seismic design codes. So just like those established by the International Building, that is the IBC and ASCE 7. These ones to ensure the compliance with the best practices for earthquakes and earthquake resistant masonry construction. Okay. Um, Masonry veneer system. The masonry veneer system serves as a non-structural cladding system that provides like aesthetic appeal while offering durability and some protection against the environmental factors. These systems commonly use materials like bricks, natural stone, and manufactured concrete units. Um, for these ones, there are some material choices that is like the brick veneers that are just like the ones that are classic and widely used for their durability and low maintenance. Those other ones are the natural stone veneers. Those are high-end aesthetic appeal, but heavier than the and requires more structural support. There are some like manufactured stone veneers. Those ones are lighter and those ones are more cost effective and natural, and those are from natural stone, and they mimic like the natural appearance. There are some design considerations in this part. There are some like the proper detailing that is essential to prevent like the moisture intrusion that can lead to the mold and if or structural damage. There are some air gaps and weep holes that allow the drainage and ventilation. And there are like the suspension joints and that serve to accommodate the thermal movement and prevent like the cracking of the wall. Um, some installation methods are the adherent veneers. They are bonded directly to the backing with a mortar and adhesive. There are the anchored veneers. Those are supported with metal and ties and brackets, allowing for the cavity between the veneer and the structural wall. There are some like the prefabricated panels. Those are already pre-assembled and those pre-assembled veneers and those are like more quicker for the installation and they enhance the quality control. Okay. Sustainability in the masonry construction. Masonry materials are inherently durable. This makes them environmentally friendly and just like however their production, particularly cement manufacturing, has significant environmental impacts. Sustainable masonry practices aim to reduce this footprint through various approaches. One of them is the eco-friendly material sourcing. This is using locally quarried stone and reduce the transportation emissions. There are also the recycle aggregates and industrial byproducts such as fly ash and concrete, and this lowers the material waste. Energy efficiency in masonry design. Masonry design thermal mass help to regulate the indoor temperatures, reducing heating and cooling demands. The passive solar design. This one is where masonry walls absorb and release heat strategically, and this can improve the building energy performance. And the last one is longevity and life cycle benefits. Unlike on other materials that require frequent replacements, masonry buildings can last for centuries with minimal maintenance. Common failures in masonry. Masonry structures, despite their strength, are susceptible to very the environmental conditions and material degradation. The most used include the crack uh, is divided structure that those are caused by the settlement, seismic activity, or improper reinforcement. Another type of cracking is the thermal expansion cracks. These ones do occur due to the temperature fluctuations and lack of expansion joints. Another issue is the spaling. Spaling, the flaking or breaking of the masonry surfaces, often due to freeze-thaw cycles, water inflation, or poor quality mortar. Another failure is the water penetration and efflorescence. This one is due to poor drainage, insufficient flashing, or porous masonry materials that can allow the water to seep in, leading to mold, structural weakening, and unsightly soil deposits in the buildings. And the last one is the preventions. The preventions and repair methods used to fix these failures. Um, the proper waterproofing, sealants, and flashing details prevent moisture-related damage. Also, like you can to prevent these things, you can use quality materials and reinforcement techniques to minimize the structural and aesthetic degradation of the buildings. And also, like you can use the regular inspections and maintenance to extend the masonry lifespan and prevent the costly repairs. The future trends in masonry construction. The masonry industry is evolving with the new technologies and methods that enhance efficiency, sustainability, and versatility. Some key advancements do include the lightweight concrete blocks. These ones do reduce are reducing the weight of the masonry units without compromising the strength, making construction easier and reducing the structural load demands. The automated and robotic masonry construction, robotics and 3D printing are revelation regulating, increasing precision, speed, and reducing labor costs. The prefabrication and modular masonry, pre-assembled masonry panels allow for faster construction and better quality control. Advancement materials and additives. The innovations such as self-healing concrete, carbon negative bricks, and high performance insulation integrated masonry improve the durability and energy efficiency. These developments will shape the future of masonry and help to make more like the buildings more adaptable to the other architectural and environmental demands.